Now we have finished a simple storm drain lesson. Now we'll be moving on to the advanced storm drain lesson. So as it loads, so I just deleted the simple one and reset it so we can do the advanced storm drain lesson. So everything should be okay. I think we just we're going to load our advanced storm drain shapefiles right here. And then what we have is a new, like we showed you on the simple lesson, we have this new advanced lesson which has this list of checks that we'll perform. We want to make sure that we do each of these because otherwise we might have missed a step. But as you can see, we have step-by-step instructions. So step 1, load the shapefiles, assign the fields. Step 2, well, where's step 3? Oh, that is step 2. Step 3, auto assign links and nodes. Step 4, add your type 4. There's 3 in this system, or 4. Actually, there's several. We'll see. You'll see how they work. So one of them is from a text file that's just like a rating table, and then several of them are from these new type 4 culvert equation system. So we'll see that. And then you can check this file after you do those, and you can actually do these together. You don't you can select this one and this one at the same time, and it will import everything. And then we'll add the pump curve, which is very easy. It's just a steady pump. Storage units, we'll add the storage units and build that storage unit table. And then there's an external inflow we're going to put in right here. So we want because this is a system that brings in quite a bit of water from this Grover Park Road or Grover Road, Grover Avenue, something like that, brings a lot of water down, and we're just going to apply it as an inlet condition right here to that junction. And then we will set the storm drain control parameters, which in this case, they do need to match our generic storm drain time series data, so that might be important. And then we will schematize and do a quick run. Okay, so let's go ahead and do that now. So we'll start with the shapefiles. They are in Lesson 3 Advanced Storm Drain Shapefiles. And we just want to sort this by type, get down here to the shapefiles, and we want all of these. Anything that ends in SHP or says SHP right there, we want all of them. And then we can put these in our storm drain group, but you don't have to save these to the, like when I click save, I can click no because I don't need those to be part of my geo package, because once I'm finished with these and I've got a good test run, I can remove them and then I can do all the work in these layers. So all this process is going to do is copy these into their correct layers. And the next thing we'll do is find our storm drain editor. And this guy right here should have remembered everything because I've already done this. But let's see, I think it's going to remember it from the storm drain simple lesson. So we'll have to select some of them. And some of them are different because this is the advanced lesson, so we're doing a bit more. So inlets and junctions, that one was remembered from the simple storm drain lesson. So the name is, I'm just going to validate these: name, type, invert elevation, maximum depth, length and perimeter, width area, height, sag or surcharge, weir coefficient, feature. Now in this one, I applied the curb height to the type 1 and 2. So we have a curb height. I applied a clogging factor to some of them. I think I applied the clogging factor to the type 1 and 2s too, and a clog time. And I applied a Dropbox area to some of the larger ones, the type 3s and the oddly shaped grates. So we got a Dropbox area that is different than the Flow2D defaults to a Dropbox area of like 4x4 or something like that. And so if you need to modify that, you can do that right here. Outfalls. I didn't do anything different. I could have added a fixed stage or something like that, but these are honestly, they don't really need it, so I'll just leave it. I do have one advanced outfall. That's this one right here. We can take a look at it in a minute. Storage units. Okay. Mainly storage units is all about removing a bunch of stuff that Flow2D will not be applying. So name is correct, invert elevation is correct, maximum depth is correct. We're not going to apply an initial depth, so we can take that one off. We're not going to apply an external inflow, so we can take that one off. And evaporation, we don't use these are not like open to the surface, these storage units, so we don't need evaporation. I don't use a treatment. We also don't need infiltration. Like I said, these are not open to the surface. These are closed. So things that are open to the surface, usually Flow2D takes care of that stuff. So that's why we don't apply infiltration to storage units and other like channels and things like that. In swmm, we apply the infiltration to the Flow2D surface. I'm going to be using a storage curve, so I don't need, so that means it's not a functional curve. So I don't need a coefficient, exponent, or baseline, but I do need a tab curve. So my storage curve type is storage curve, and it's a tab curve. And then this is the name of the curve, which I think is called storage 1. Conduits. So we don't need these two because they will be processed by this button here. I don't think there are any inlet or outlet offsets in this particular model, but if there were, you could just apply them through a field. This would be the shape, and I'm pretty sure that our shape is all circular at this point still. So if you have a different shape, you would need to apply one of these other geometries, but typically it's only one or two of these that you would apply. Number of barrels, the maximum depth, and again, that's got to be in feet. So this is circular, and that's going to be in feet. Length, Manning's roughness, initial flow. I don't have any initial flow or max flow for these conduits. I suppose I could do a max flow, but I haven't done anything like that. Entry loss coefficient. I did put some entry, exit, and average loss coefficients in this. So entrance loss coefficient, exit loss coefficient, and average loss coefficient. And I did those loss coefficients per some instructions that came from this guide right here. So this guide right here has some like relatively straightforward and kind of functional ways to like look at losses and apply losses from different scenarios. And it's relatively extensive, and you can just look up the tables. It's usually pretty helpful. I also asked for some help from ChatGPT to help understand this. So, to like, why is it doing this? And it has some pretty good, I'm not going to say it's perfect, but it does have some pretty good ideas on like how to do specific things. Here's a change in diameter, and then here are like some 90-degree bends and manholes and stuff. So like, how do we handle these certain conditions? And I asked those questions to ChatGPT, and also used this diagram and this manual to make sure that those values were like in an appropriate range. So there are some loss coefficients in this one. And of course, whether or not there's a flap gate, you have, I don't think we have any flap gates on any of these conduits. So that ones are all probably set to no. So flap gates are like either yes, no, or 0, 1, I believe, or on, off. Now I think it's yes, no, or 0, 1. It's a Boolean, so maybe it would accept all of those answers. Pumps. Here are the L3 pumps. And again, the name is fine, but we don't need the inlet outlet. We'll apply that through this guy. And initial status is important. Start depth, stop depth, that's also important. Curve name, our pump curve is called P1. And then we don't need these guys right here because that will be applied down here. Orifice. And so again, we don't need these two. Name, type, this one's wrong. That should be inlet offset. Q coefficient is okay. Flap gate, time, open, close, that one's wrong. So that should just be open, close. Shape, height, and width. And if you want this to actually find that, it's probably going to be, it's probably looking for the word time. Okay, weirs. And name is good. Don't need these two. Type, this one's wrong. That needs to be inlet offset. This one's wrong. That needs to be Q coefficient or discharge coefficient. That's probably looking for discharge coefficient. Flap gate is okay, and contraction is okay. This one's wrong. It needs to be N coefficient. Side slope, shape, height, length. That's okay. And then of course you would just check them again real carefully just to make sure that the ones that are commonly incorrect are now okay. Conduits, okay, pumps, and orifice, and weird. And then we click Assign Selected Fields, and that'll take a bit of time. And then once that's finished, you can sort of turn these, you can just uncheck these because you're kind of finished with them, unless you realize that, something went wrong and you need to redo them or something. Sometimes you accidentally use that wrong field when you're assigning these, and you don't need to assign, you don't need a shapefile. You can build your storm drain directly into these layers, or you can import an IMP and it will fill these layers. But for this tutorial, we have these shapefiles because it makes a nice little templates. Okay. So 274 conduits, 1 pump, 2 orifice, 1 weir. And this value right now is assigned to the missing inlets or outlets. So now what we have to do is fill those inlets and outlets. So I'll click OK. We also got 2 error messages that might be in the log. Let me take a look and see if those are in the log message panel. Let's see. It says, yeah, here they are. This junction is out of the computational domain, and these outfalls are out of the computational domain. So we knew that. Now, if you have something outside of the computational domain, it cannot be an inlet. And if it's an outfall, so it has to be a junction. And if it's an outfall, it cannot have the allow discharge back to the grid condition has to be set to 0. So let's take a quick look at that condition. First of all, we can turn these off like I said we were going to. Let's go ahead and turn these off. And let's go, I guess you just select them all, and then you click this eye, and then just hide selected layers, okay? And before I get too heavily involved in this outlet condition, well, I guess we can show that right now because I showed you this log, so that's a good time to show it. So if you use this button right here, Flow2D Info Tool, and then you click on one of these outfalls, you can see that it is 0 discharge off the grid. So that means these 4 act as a sink. And I set those up intentionally to show you how a sink would work. They would actually be discharging to this channel right here if I was using those correctly. Okay, there's another outfall up here that's like, as you can see, let's grab one of these guys. So these guys, these outfalls right here, they are set to 1, allow discharge to the grid. And then this one up here, not positive, but I think this one should be set to 2, but let's see what it's set to. Yeah, this one is set to 2, allow discharge to the grid, but do not allow that initial depth. So if you have an underground or bubble up type outfall, like when you first start Flow2D, if you have it set to 1, then it's going to fill water to the surface of the grid. And that's not really the way that we want that to work, because that can cause initial instabilities and it can cause movement of water in here for no reason. So it's almost like setting it to the groundwater table, which, in Phoenix makes 0 sense. Like maybe in Florida that's okay, but not in Phoenix. So we're going to set that one to 2 and try to see if that's flowing correctly. And then the outfall type is usually free or normal in this case. Okay, that's outfalls. Now, another thing about the outfalls is that they have to align to the left bank. But before I start moving and aligning things, I do want to come back and set and quickly do this before I forget. I want to auto assign links and nodes. So that'll be 3. Yes. And I don't know why we got the warning, but this is what we want to see right here. And it's going to basically tell us that, well, what do we want to see? We want to see these to be 2 check marks. We don't want to see any question marks in here. That's the important thing. If you see a question mark in here, it will be reported to the log and possibly here, and you'll be able to zoom to the ones that need to be fixed. And why would they need to be fixed? It's because the node that the conduit is connecting to is more than 3 feet away from it, and so it can't find it. okay? But I don't recommend using a buffer of greater than 3 feet because that might accidentally pick up a second node, and then of course it becomes like an alphabetical or index thing to decide which one becomes assigned to that conduit. Okay, next is, let's see, what's next? Let me go back to the documentation here. So let's go back to storm drain and load the shape files, assign the conduits, assign the nodes. Oh yeah, check to simulate storm drain, add the rating tables. But before we do that, there's one step I forgot, and that is adjust the outfall positions. So I should probably put that in as a step. So let's take a look at each of these. Now we need our outfalls to be sort of right next to a left bank. So that means they need to be sharing a grid element with the left bank. These two are fine, even though that one's right on the boundary. It's fine because it's inside that left bank grid element. This one's fine. See, inside it, no problem there. Doesn't matter about this guy right here. That would be taken care of some other way. Okay. These two are okay, and they're also away from this guy. That's important. This one is okay. This one is not okay. So let's go ahead and show you how to fix that. So what we'll do is we'll select both of those, click Edit, and then click the Vertex tool. Make sure your snapping is on. If you can't see that, you'll right-click Toolbars and you'll go find the snapping toolbar, okay? So snapping is on in this case, and we'll just put it right to the center of that. I think there's a few more that are also wrong. That one's okay, that one's okay, this one's no good. Got to move that one. Okay, and that one needs to move. Okay, all good. See how that snapping rectangle or snapping, okay, that one's okay. That snapping is applied. That one's okay, but it's right on the edge, so we can just move it if we want. It won't really matter. It doesn't have to be directly on that center node. It just needs to be inside that grid element. And then of course these 4 are not on our channel. So now I can come over here. I'm still have both of these selected, right? And if I turn this off, I can just click save, save, and then those are now ready to go. All right, coming back to our documentation, we need to add the type 4 and check this switch. So we can check the switch. It's already good. Come here, down here, there's no type 4s in here, so we need to import them or create them. So if you want to create them, you'll add either a rating table or a Culvert equation. If you want to import them, you can add this one. You just click on this, and the rating tables are in the advanced storm drain folder, and we need 2 of them. We need this one and this one. Go ahead and click open, and those will be imported. And what's just happened inside there is that we now have a, hang on, there should be a file in here called rating table warnings.out or something. No, rating table warnings.txt maybe. Here they are, rating table warnings.check. And this is just to confirm that we did assign a table to these inlets, or a Culvert equation, or like this one was a table, and these 1, 2, 3, 4, 5 were Culvert equations. So what you're looking for is you don't want any of those to say that it didn't happen. I wonder if that gets reported to the log. It doesn't look like it. Too bad. That should be reported to the log. Okay, next thing we do is go ahead and take a look at some of these. So here's your rating table, and here is your Culvert equation. Let's do this. So in your Culvert equation, you get, well, your rating, let's do rating table first. So here's your rating table. So you can see it's just like a hydraulic structure rating table. This is just a head water controlled rating table because the storm pipe system will apply the control downstream. So all we need is the headwater inlet control for upstream. And then if you do this one, it becomes like a generalized Culvert equation, but of course your conduit, there's certain things you don't need, like your conduit diameter and things like that. So multiple barrels. This would be the width. If you set this type equal to 2, then this width becomes a 0 because it's a diameter, right? Entrance type, this is 1 for box culvert or rectangular culvert and 2 for circular culvert. And then this would be the diameter of the opening. Okay, the diameter of the opening. All right, and that's how you define those type 4s. And again, you don't have to have those tables. If you don't have those tables, you can build them with this table editor right here. All right, let's go ahead and see what's next. So we did our type 4s. We showed you all about that. Now we need to do our pump data. Let's go ahead and do this. So we come back here, and what we need to do is this right here. We need to add a pump data, pump curve. It needs to be a type 4 depth and discharge, and then we can just put this description like that if you want. Or you can, it looks like you can also load those, but I think it would just be X and Y would what it be loading. And so our X and Y over here is 0. And then I started at like 3 feet, 20 CFS, and then I up to 10 feet, 20 CFS. And I think that in your pump curve, if you go find your pump, which is right in here, but your pump curve will show you, will also, so if I'm on this guy right here, so if I click that pump, you can see that I can load that pump, and this, oh, sorry, that needs to be set to P1. So I'll have to do that. Sorry, I apologize. I was supposed to do that right here. Sorry, that's got to be P1. And then this, actually, I need to delete this one. Okay. All right, now let's go back to that pump. And now you can see that's supposed to be, hang on, let me close that and reload it because it didn't refresh. So let's reload that. And this is, see, now it's set to P1 because that matches the attribute inside here. Initial status is either off or on. There's only 2. And then this would be like startup and shut off depth. Now these ones are a little silly because basically we're telling it not to shut off, but let's go ahead and just set that to 10. Actually, I'm not really sure what that would do. And then usually I think you do this, you do something like shut it off at, like 2 feet and turn it on at 6 feet or something like that. So I kind of have this a little bit backwards, but I think you get the idea. And if you need any help on any of these, you can go to OpenSwmm. They have a lot of good examples of pumps. And then you can ask ChatGPT to build you an example of a swim pump, for a specific configuration. And it'll help you kind of figure out the right data to put in for your pump. It'll also help you figure out rules and different things like that. Okay, what's next? I guess we just go back to the manual because I forgot what was next. Okay, that's all good. Oh yeah, the storage units. Okay. So our storage units are these 3 right here. Now what I tried to do here, this is kind of a big building. Let me show you. And so what I was trying to think of is like the runoff of this building is stored in a cistern. That was my thought for this, even though I know that doesn't really happen in these huge commercial buildings. So, but it's okay just to think about it. I mean, I do know that there are sometimes underground storage units in these sort of parking lots, but and that typically speaking, these will have like some kind of drainage. You can sometimes see on these buildings some kind of that they have some kind of drainage assigned to this side, and sometimes they will run off onto the parking lot. And you can even see in cases here some looks like some staining on the concrete, or excuse me, on the paving, not concrete, that shows that sort of runoff. And they might be like running over here into this, directly into this basin, and there'll be little holes in these sidewalks to help, or in this curb right here to help that water get off there. But what I was thinking is we could put like an underground system off of this building, and that just apply that as inlets from the top of the building. So the water just flows this way from the building. And then this pump, and then storage unit, storage unit, storage unit, and then this outfall could like maybe fill this basin. So it's just a game. It's just a guessing game. I mean, this is just like a design type of feature. It doesn't actually exist. So here's your pump. I think this is an orifice. This is an orifice. And this is a weir. And I didn't set those, like, that's not very realistic, for this kind of scenario. I just set that up so you could see how to use those types of links. Okay, so let's close that up. Again, if you're interested in how to apply things like orifice and weir, go to OpenSwim or go to ChatGPT and start asking some very specific questions, and you'll get some pretty good feedback and some pretty good help on how to model these kind of things. So we have to set up the storage unit. So if I click the storage unit and I go and open its attribute tables, you can see that its name is cistern1. These are some of its properties. And what we need to do is we need to build a curve for it, okay? So if I go here, and then we want to name it storage 1, and then this will be, oh, I think the description's actually going to load. And then we click load file, and I have a storage 1 curve right here. You click that open, and then you see here, it's just a horizontal cylinder with a depth and an area. And this, calculates the volume of it as the flow enters it. And then you click OK. And now you don't have to do that again because these ones are all exactly the same. So you can see here that they're already ready to go. So you don't have to do that for all 3 of them. And then we're actually finished with this, so we can close it. And the next step will be to add an external inflow to this Grover Street junction. Let's just make sure that we do this right. Okay, looks good. And I think I just copy paste that into here. So let me go ahead and let's just go find that inlet or that junction. It's not an inlet, it's a junction. And we'll click it, and then we'll go and select the attribute table. And this gets set to yes, and this gets your flow properties. So we're just going to use a time series. So I click this button right here. Let's see, I think I have to do some things here. I think that we add this. Let's see, one of these is manual. I think, yeah, use this table. I think we put this in here manually. Grover time series. Okay, let's do it. So this is Grover time series, and this is generic or fake time series data. Okay, and then we're going to use this table, and then we go to our time series table here, and we just, you see these are tabs, that's important, and we just select all of these guys and copy it. And what we need in our table is, this is the month, day, year, this is the time in hours, and this is the value. So I think what we can do is just put our cursor right here and click paste. And then you'll see that everything is in there correctly. And like I said, it's just a fake time series. So it just starts at 10 CFS, goes up to 60 at hour 6, and then back down to 0 by hour 10. So it's just a fake, sorry, 60 by hour 5. So we'll just save that, close this, and then go back to QGIS. I think we have to close one more. So yeah, let's see. I think we can just click save, and then that is complete. And then I believe the next thing we have to do, I don't want to miss anything. So let me just check. Whoops, wrong one. Sorry. Let me just check and see. Storm drain control parameters, and then just make sure that that is matching our Grover time series data. So that's 0101-2020. And again, that's not realistic data because that's just it's just placeholder data, because none of our modeling data needs to be synchronized to anything else. So if we had this like on a tide table or something, then we would need to synchronize this to that tide table. But since it's not, we can just put in this generic data right here. All right, so let's do that right now. Let's go here. This is the storm drain options. And you can edit this if you want. You can put, that maybe that was created by your company or whatever to help people track it. Time control parameters. So that's 01 dot. Oh, see, this is so annoying. let's see. Yeah, you can't delete it. You just have to change them individually. So 0, 1, 0, 1, 2, 0, 2, 0. Same thing here. 0, 1, 0, 1, 2, 0, 2, 0. And because we aren't passing 24 hours, it's still 0, 1, 0, 1. Okay. And the start time is the start of our simulation, so that's 0 hours, and the end time is the end of our simulation. So this is our simulation time for the project. And then this report step, so this is important to get this right, or else your storm drain will end too quickly. And this is the report step, so we're going to get information every 0.6 hours. Okay, let's see. And yes, on all these, and then these advanced properties. So we're not going to skip steady state. You can choose which of the equations you want. The link offsets can be either depth or elevation. And this can be set to whatever minimum slope you want. This will be your minimum slope threshold. So if you have a pipe that's completely flat or conduit that's completely flat, storm drain systems don't really like that. Sometimes you'll see storage units that are like really flat like that. So you might want to like maybe not use a conduit in that instance and instead apply a storage unit. And these guys are all hardwired. So this is hardwired because this coordinate system is in the units of US feet. And so that's why this is cubic feet per second. Now this is hardwired. So even if you modified this, it would still use dynamic wave. You can't modify it with the flow 2D properties, but you could definitely modify it in the IMP file because of course that's just a text file. This is set to partial, this is set to both. So all those are hardwired. And you click OK, and that's complete. Let me see what's next. I think the next thing to do is to schematize it. And then I believe the final thing to do is a test run. So I'm going to, now what I've already done is I have already done an advanced storm drain run. So I just want to check in, make sure that it finished. Okay, yes, it finished. So, and now what I'll do is I will just put in a test folder because we're just going to check this to see if it runs. If it runs without any error messages, then that means we don't have to fix anything. So quick run. And then we go in here to our test folder. And then we just click OK. And that's starting to export our data. And then as soon as I click OK, the run starts. So be careful to click that final OK. You don't want your computer sitting there overnight because you've missed that final OK. That's new, I think. All right, so because the model started running right away, that means it passed all its checks. That doesn't necessarily mean everything is right, but that means it passed all of its checks. So then the next thing we'll do is let that finish running, and we'll start the advanced storm drain review. So the simple storm drain review is already on YouTube. The advanced storm drain review comes next.